Hello everyone. Today we are going to see about CPU scheduling algorithms under operating system. In previous session itself, we have seen what is FCFS, first come first serve scheduling algorithm, and we have seen an example problem to solve under FCFS scheduling algorithm. Today's session we are going to see about SJF scheduling algorithm. SJF scheduling algorithm stands for shortest job first scheduling. As per the name, the process which are arriving in the queue and which has the minimal burst time will be allocated for the execution in the CPU. This is known as SJF scheduling algorithm. Comparing to the four algorithm types, which is FCFS, SJF, round robin, and priority, this SJF scheduling algorithm will be resulting with the average minimum waiting time. So this will be considered as an optimal algorithm for process scheduling in the CPU. Let's see an example for solving this today. And as said in the last session, these are the definition of a Gantt chart: waiting time and turnaround time. Gantt chart is nothing but an bar chart, and it is a pictorial representation which contains the starting and completion time of the process execution, and waiting time is nothing but the time period spent by the process in a waiting queue, and turnaround time is nothing but the waiting time of the process along with this execution time. So turnaround time is the sum of waiting time and its burst time. Okay, these are the formulas we are going to use for finding the turnaround time and waiting time today. Turnaround time equal to completion time minus arrival time, and waiting time equal to turnaround time minus burst time. Let's see an example. In this example, the inputs given are the process, its burst time, and its arrival time. There are four processes, and P1 arrives with the burst time of 6 millisecond, and P2 arrives with the burst time of 8 millisecond, and P3 arrives with the burst time of 7 millisecond, and finally P4 arrives with the burst time of 3 millisecond. And let's consider all these four processes arrives at the same time period of 0 milliseconds. Okay, the first we will be finding from this input is Gantt chart. As said, in this SJF scheduling algorithm, the process which has the lowest burst time will be allocated for the CPU first, right? Let's compare all those four processes and its burst time. Considering P1, P2, P3 and P4, the process P4 has the burst time of 3 milliseconds, which is lowest while considering 6, 8, 7 and 3. So the process P4 will be allocated for the CPU first. So the process P4 starts at the 0 millisecond and it executes till the completion of process P4. So the completion time of P4 is 3 milliseconds. Then next, the process P1, P2 and P3 are now in the waiting queue. Comparing these three processes, the process P1 has the minimum burst time of 6 milliseconds. So next P1 will be allocated for the execution. So P1 starts at the time of 3 millisecond and it ends at the time of 9 millisecond. That is 3 plus 6 equal to 9. 9 is the completion time of process P1. Then now P4 and P1 has completed its execution. The waiting to process are P1 and P3. Now we are comparing the burst time of these two processes. P1 has 8 milliseconds and P2 has 8 milliseconds and P3 has 7 milliseconds. Comparing these two, P3 has 7 milliseconds is the minimal burst time. So next P3 will be allocated to the CPU for its execution. So P3 starts at the time of 9 millisecond. 9 plus 7, P3's burst time equal to 16. 16 is the completion time of process P3. Then finally P2 is available in the queue. Next P2 will be allocated for the execution. P2 starts at the time of 16 millisecond. 16 plus its burst time 8 equal to 24. 24 is the completion time of process P2. This is a Gantt chart. From Gantt chart, we will be finding the turnaround time and waiting time of each process, and we will be deriving the average turnaround time and average waiting time, right? First, we can find the turnaround time. What is the formula for finding the turnaround time? Turnaround time equal to completion time minus arrival time. So, first we are going to find the turnaround time for the process P1. For process P1, the completion time is 9 minus all the process arrives at 0, right? So, 9 minus 0 equal to 9 is the turnaround time of process P1. Then next process P2. P2's completion time is 24 milliseconds. 24 minus arrival time 0 equal to 24 milliseconds is the turnaround time of process P2. Then for P3. Process P3's completion time is 16 milliseconds minus its arrival time 0 equal to 16 is the turnaround time of process P3. Then process P4. Process P4's completion time is 3 milliseconds minus its arrival time is 0. 3 minus 0 equal to 3 is the turnaround time of process P4. Then we are going to find the average waiting time of all those processes. Average turnaround time. For finding the average turnaround time, we will be summing all the turnaround time of the process P1, P2, P3 and P4. 9 plus 24 plus 16 plus 3 equal to 52. 52 divided by 4 equal to 13 milliseconds is the average turnaround time of this process execution in SJF scheduling algorithm. Next, we are going to find the waiting time using this turnaround time. What is the formula for waiting time? Waiting time equal to turnaround time minus burst time. Using this, we are going to derive the waiting time of all those four processes. First, we are going to see for process P1. Process P1 turnaround time equal to 9 minus its burst time is 6 milliseconds. 9 minus 6 equal to 3 is the waiting time of process P1. For P2, the turnaround time of P2 is 24 minus its burst time is 8 equal to 16 milliseconds is the waiting time of process P2. Next, for process P3, its turnaround time is 16 milliseconds minus its burst time is 7 equal to 9 milliseconds is the waiting time of process P3. For next process P4, the turnaround time is 3 minus its burst time is 3 equal to 0 is the waiting time of process P4. Then for finding the average waiting time, we will be finding average for P1, P2, P3 and P4, right? So 3 plus 16 plus 9 plus 0 equal to 28 milliseconds. 28 divided by 4 equal to 7 milliseconds is the average waiting time for this process execution in SJF scheduling algorithm. As said before, if you solve the same process under FCFS round robin priority, we will be having the minimal waiting time in SJF scheduling algorithm. So, in general, SJF scheduling algorithm will be considered as optimal algorithm with minimal average waiting.